Decision tree learning is a supervised machine learning algorithm, and it can be used for regression as well as classification tasks. Further, it mimics humans' decision making process and is very effective in several applications. Hi everyone, I am Bindeswar from Post Network, and in this video you will know about how to construct a decision tree learning model using Gini index. So let's get started. To demonstrate that how to build a decision tree learning model, I have taken weather data set which has 14 instances and 4 independent features: outlook, temperature, humidity and windy, and one independent variable or class variable. The supervised learning problem setup is that based on 4 features: outlook, temperature, humidity and windy, class label is assigned that a player will play tennis or not, and there are 2 types of classes: yes and no. So you can say that this is a binary classification problem, and all independent and dependent features are categorical. And see that 2 types of classes, yes and no. Yes has 9 instances, no has 5 instances. And see that to construct a decision tree model, we will use Gini index, which is used for CART algorithms, classification and regression tree algorithm, which is the umbrella term, which you can say that the decision tree learning algorithm which are using Gini index. Gini index is defined as 1 minus summation over pi square, where pi is the probability of an object being classified to a particular class I. See that the Gini index measures the probability for a random instance being misclassified when chosen randomly, and you can say that misclassification rate it indicates. So better when Gini index is low. So now here I am going to calculate Gini index for outlook, value sunny. So if you see that outlook feature having value sunny, it has 5 instances, in which it has 2 yes classes and 3 no classes. So Gini index would be calculated for outlook feature value sunny 1 minus 2 upon 5 whole square minus 3 upon 5 whole square. So see that how value is calculated, and thereafter we will also be calculating Gini index for overcast, and another value of outlook is rainy. So you can see that Gini outlook value Shani, which is 0.48. Now Gini index for outlook feature value overcast will be calculated. So you can see that there are 4 instances of overcast. You can say that outlook feature has 4 values having value overcast. See that all are yes. So if all are yes, so Gini index would be 0. Now see that Gini index for outlook feature value rainy will be calculated. So you can see that there are 3 instances of yes, or 3 classes are yes, 2 classes are no. So the Gini index would be 1 minus 3 upon 5 minus 2 upon 5, and finally it would be 0.48. Now if you take weighted average, so that would be 0.348. So this is Gini index for outlook feature. Now we will calculate Gini index for a temperature feature and value hot. So you can see that for temperature feature there are 4 instances of hot having 2 yes classes and 2 no classes. So Gini index is 1 minus half square minus half square, and that would be equal to 0.50. Now Gini index for a feature temperature value cool would be calculated. So you can see that there are 3 yes classes and 1 no class. So Gini index would be calculated 1 minus 3 upon 4 square minus 1 upon 4, which would be equal to 0.375. Now third value is mild. So for a value mild feature temperature there are 4 classes are yes and 2 classes are no. So Gini index would be 4 upon 1 minus 4 upon 6 whole square minus 2 upon 6 whole square, and that would be equal to 0.4555. Now all Gini indices are calculated for temperature values. Now you will take weighted average, and that would be equal to 0.439. Now the third feature is humidity, and for feature humidity and value high we will calculate Gini index. So you can see that 3 classes are of type yes and 4 classes are of type no. So Gini index would be calculated 1 minus 3 upon 7 minus 4 upon 7, and finally that would be equal to 0.90. Again, for the value of normal feature humidity, Gini index would be calculated. So there are 7 instances in which 6 instances are of type yes and 1 instance is no. So Gini index would be calculated 1 minus 6 upon 7 square minus 1 upon 7 square, and that would be equal to 0.245. Now weighted average of Gini index would be calculated, and that would be equal to 0.367. Now Gini index for a windy value false would be calculated. So you can see that there are 8 instances in which 6 are yes, 2 are no. So the Gini index would be calculated 1 minus 6 upon 8 whole square minus 2 upon 8 whole square, and that would be equal to 0.375. Now Gini index for a feature windy value true would be calculated, in which you can see that there are 6 instances, and if you see about classes, so 3 are of type yes and 3 are of type no. So Gini index would be 1 minus 3 upon 6 whole square minus 3 upon 6 whole square. So that would be equal to 0.50, and see that the value has come 0.50. It means that classes are uniformly distributed. Now weighted average of Gini indices would be taken, that would be equal to 0.4284. Now if you see that Outlook has the lowest Gini index, and that is good for classification. So Outlook would be selected as root node, and its 3 values would be branches: sunny, overcast and rainy. And for sunny there are 2 yes and 3 no, and for Outlook all 4 are yes, for rainy 3 yes and 2 no. Now see that root node is selected. Now which one would be sub node? So we will calculate again Gini index, given Gini index of Outlook feature is already given. So I am going to calculate Gini index outlook is equal to sunny for temperature. So you can see that for a value of two instances of sunny, temperature hot has two instances and both are no's. So see that in this case the Gini index would be 0. See that Gini index is outlook is equal to sunny, means Gini is already, and temperature hot, that is 0. That means that for a sunny and hot, all classes are of same type. And see that here for a sunny and value of temperature cool, there is only one instance which is yes. So Gini index would be calculated, and thereafter after cool, Gini index for outlook is equal to sunny, temperature mild would be calculated. So you can see that Gini index outlook sunny, temperature cool, it is also 0 because all classes were of type S. Actually there was a single class. Now for value sunny, outlook feature, temperature value mild, Gini index would be calculated. So there are two instances, and one yes and one no. So Gini index outlook value sunny, temperature mild, that would be 1 minus 1 upon 2 whole square minus 1 upon 2 whole square, and finally that would be equal to 0.50 here because all classes are uniformly distributed. So it would come 0.50. Now weighted average of Gini indices would be calculated. So that is 0.20. Now for the feature outlook value sunny, we will test humidity. So in this case 3 instances are no's, all classes are of no. So you will see that the Gini index will come 0 because 1 minus 3 upon 3 whole square, that would be equal to 1 minus 1, that would be equal to 0. That means sunny, feature outlook, and humidity high, all would be no's. Now see that for a humidity normal, outlook sunny is already given. There are two values which are yes. Again see that the Gini index would be 0 because all classes are of same type which are yes. So Gini index would be 0. So finally what will happen for a value sunny, feature outlook, humidity, the Gini index would be 0. So Gini index would be 0. Now for the feature windy, outlook sunny, outlook feature value sunny, Gini index would be calculated. So you can see that there are two classes, yes and no. So in this case the Gini index will come 0.50 because classes are uniformly distributed. So in these cases Gini index will always come 0.50. Now let us calculate Gini index value, Gini index feature outlook value sunny, windy value false, and in this case there are one yes class and two no's. So the Gini index would be calculated 1 minus 1 upon 3 whole square minus 2 upon 3 whole square, and after calculation I will take weighted average of value Gini index of windy true and windy false, where outlook feature value sunny is already given. So you can see that all three values in which humidity has the lowest value. So below sunny branch humidity will be subnode because Gini index outlook sunny, humidity which is equal to 0, the lowest value of Gini index. So that would be the subnode. Now see that if you see the value of outlook feature here for a sunny and temperature humidity high, if you see that feature outlook value sunny, humidity value high, so all are mapping to class no. So that would be, you can say that leaf node, because no is a class. And in the same case like no, if you see that for a value sunny feature outlook and feature humidity value normal, both you can say that are classes of yes, both classes are yes. That means that for branch sunny humidity branch normal, that will be mapped to yes. So that would be terminal node, or you can say that leaf node. Leaf node means there is a class value. Now see that if you see about overcast, so overcast, for only overcast all class values are of type yes. So you can see that For a branch overcast, you can say that the class would be yes. So you don't need to take help of other features. Overcast, it means that the class is yes. Now we are left with feature windy and temperature, which is not being used. See that here for feature outlook value rainy, 3 values rainy, windy is false, and which is yes. 2 values of rainy, value true for windy feature, which is no. So without calculating, you can say that for a windy, if that is true, so class would be no. And for a branch false, for the branch false, that would be yes. So this is the complete tree. We have used Gini index for constructing a decision tree.